All right. So welcome to EE310, which is Signals and Systems, Spring 2021, the first class of this. So what we're going to do today is I am going to just give you an overview of what this course is going to be about. And then, once I do that, so then we may start with some basic background information, background review of concepts involved. My name is Momin. Let me just spend a few minutes introducing myself. So I did my bachelor's in electronic engineering back in 2002 from GIK, from just the Ghulam Ishaq Khan Institute of Engineering Sciences. And before this, the schooling was from all over Pakistan. I did my matriculation, for example, from Quetta, my FSC from Jhelum, and school before this was really all over Pakistan. Then after I got my degree in electronic engineering, I went abroad to the US. I got my master's from Texas A&M University in 2006, and then my PhD from the same university in 2010. And that's when I came back to Pakistan, joined LUMS, and I have been at LUMS ever since. So it's been 10 years now, going strong at LUMS. Okay. So what we're going to do today, as far as the course overview is concerned, I'm going to go do two things. So the first thing I'm going to do is I'm just going to quickly go over the LMS, the course page, and some of the important things that we're going to see there. Okay, and which we're going to be using throughout the semester. Right. So the first thing is, so I sent out an email last night. How many of you got a chance to go through this course page, homepage? Anyone got a chance to do it? All right, so at least one. Hassan got a chance. Nobody else did. Musa also got a chance. Right, nice. Right, so I mean, when you open up the LMS page, this is the screen that you're going to see first off, right? And I mean, if you're wondering what this is, we're actually going to see maybe perhaps towards the middle of the semester, I mean, what this corresponds to. But let me just quickly see, I mean, anybody has any idea of what this graphic represents? Gzen. So the net tickets, I'm not going through the net tickets because you've been through this online semester, last semester as well. Okay. You can unmute yourself and speak up. I would actually prefer you, or you can type in your answer in the chat box as well. But I would actually prefer that you unmute yourself and we have that interaction one-on-one. So Zen, that's sort of correct, but not in our context. I would okay, that's fine then. Somebody else raised their hand as well. Hassan did. I forget.
Yes, sir. I did.
Okay.
So this is basically a combination of sine waves making this wave, the square wave that we have.
All right.
And on the side we have, I believe, amplitudes.
Okay.
The blue.
How do you know this, Hassan?
Sir, I'm a physics senior. I've seen.
Oh, sorry. Okay. And somebody else. Right. So what Hassan pointed out was actually correct, and that's perfectly fine if you don't know this already. But these are the kinds of things that we're going to be looking at. So what it really is, if you start adding up sinusoids, it turns out, and that's really the beauty of that analysis done many centuries ago. It turns out, okay, you add sinusoids up, you can perhaps get a square wave, right? So that's some of the things that we're going to look at. So that's just a brief comment on what this graphic represents. And this is very, very representative of the kind of things that we're going to be doing throughout the semester, right? So you open up the course page, but that's where we were. You open up the course page, this is what you see. You're going to see all of the announcements here. And so the welcome announcement was sent last evening. So you're going to see all of the announcements here. This is going to be the calendar. And I'm going to populate this calendar pretty soon with the class schedule, of course, the class schedule, as well as the office hours and any deadlines that are going to come up. So I'm going to ask the TAs to fill this up. So this is going to be a quick reference, a quick guide to the upcoming deadlines, upcoming events, and so on and so forth, right? This is where all the information about the class schedule is, and I'm assuming because you've joined through this link, so you've seen this already. And these are the office hours. I've not populated that yet. We will be doing that by the end of this week, inshallah. The TAs for this course are Saeed. I'm not sure if he's here. Saeed and Zehra. Both of them are doubly juniors, and they will be assisting me with this course throughout the semester, right? So the first thing I'm going to do is I'm going to open up the course outline. Okay, before I do that, let me also take a moment to introduce some other features that we're going to be using a whole lot. So lessons is a tab that I created, I think this morning. And this is, like I said in my email as well, this is a one-stop shop for all information related to the course, right? So if I open this up, so this is something that you're going to see. Perhaps your view is going to be different. Mine looks something similar to this, what you see on your screen, but yours is not going to be a whole lot different. So what you have is all of the lecture content that we're going to have, the recorded lecture content, all of that is going to be put up on this page, right? So I'm going to make all of my notes on OneNote, and I am going to share the link to that notebook with all of you, so you can view it whenever you want, and it's going to be updated live. Any changes that I make, you're going to be able to see them. And on top of that, I will also be converting all of the notes module wise to PDFs, and I'm going to be putting them up here. The links to those resources are going to be available here. The links to the YouTube videos are going to be available here as well. I often use these video timestamps so that we can break down the 1 hour 15 lecture into smaller modules. And I'm going to do that in after the video has been recorded. I'm going to put up the stamps, and that would provide you with easy access. I'm going to perhaps explain this in the next class as well after I've done some video timestamps for at least one of the videos. Okay, and this is going to be followed up with suggested readings from the textbook and so on and so forth, right? So the link is not here yet. I'm going to put it up as soon as it's ready. Similarly, the YouTube playlist link is going to be put up here as soon as it is ready, right? So the other tab that you're going to be using quite a whole lot is assignments. Of course, this is nothing here yet. So all of the assignments, the exams are going to be managed through this tab, perhaps this one or tests and quizzes, I'm not sure yet, but most likely from the assignments tab. And the others, I think you're already familiar with. Resources is where everything is, all the files are going to go. However, the links for all of those files are going to be available. So this is lessons is perhaps the one-stop shop that you're gonna have for everything related to the course. Okay, so let me go back to the overview and go through the course outline. So have you had a chance to look at the course outline? How many of you have had a chance to look through the course outline? Right. So I'm going to wait for a few seconds maybe to see how many of you had a chance. If you have had a chance, please raise your hand. Okay. All right. So quite a bit. All right, but nevertheless, I'm going to go through this again. So the instructors' names, the TA's names, 3 credit hour course is a core course for double E majors. You would have gone through this description. I'm not going to do it because I'm going to give you a review anyway in just a bit. What I wanted to focus on for a bit is perhaps first of all the course teaching methodology, right? So this is the teaching methodology. As you know, the entire semester we're going to be online. We're not going to be able to return to campus because of the class size that we have. And when we're online, all classes, as you know, would be conducted online on Zoom in a synchronous fashion. So we're going to have live lectures, 1 hour, 15-minute lectures twice a week. And the content is going to be recorded and is going to be shared and will be shared with the students. So Mustafa, exams on campus, I'm not exactly sure yet, but we're going to know soon enough. Okay. But we don't know yet. All right. Recordings are going to be made available. And then as far as the grading is concerned and the breakup is concerned, we're going to have, so this is going to be slightly different from what maybe you're used to, in the sense that I'm going to try to divide the course into 5 modules. And for each of the modules, we're going to have an exam, right? So there's no midterm as such, there's no final exam such, but rather we just have 5 exams and distributed almost evenly throughout the semester. And then each exam is weighted 20% in the sense that out of the 5, I'm going to pick the best 4, and that's going to make up 80% of your course grading. And the remaining 20% is going to be homework. And we're going to have approximately 5 homeworks as well, perhaps a little more than 5. So this is just, once again, tentative. So the numbers may go up or may go down, right, slightly. And as far as the course content is concerned, I think there's no point in going through the exact contents yet. But what is, so Muneem, do you have a question? Right.
I'm sorry, sir, it was raised from.
All right, and that's fine. Ahmed, do you have a question?
No, sorry.
Sir, I do have a question.
Yeah, please go ahead.
सर ये एग्जाम्स का पैटर्न क्या होगा, मतलब जो 4-5 आप एग्जाम्स बता रहे हैं?
I mean, so आप क्या समझते हैं कि क्या पैटर्न होना चाहिए?
नहीं, I was asking because हमारा एक बार पहले भी एक कोर्स हमने जो पढ़ा था उसका था कि all MCQs थे वो मॉड्यूल्स, जो ऐसे एग्जाम्स थे, तो इस तरह का तो नहीं होगा?
Signals and Systems, as you're going to find out, is a course which cannot be done through MCQs. It's a very, very mathematically rigorous course. So it's a maths course, basically. So, I mean, there may be some MCQs, but that's going to be only a small portion of the exams, right? Does that answer your question?
Right, thank you.
Yeah,
thank you.
Assalamu alaikum, sir. I want to ask him, 2 will be post module 1 or it will include the syllabus of module 1 too?
No. So, so that's perhaps this is something that I like. I mean, by design, this is going to be, these are not comprehensive exams. So exam 1 is only going to be from these modules, from the first 7 lectures. So for instance, approximately the first 7 lectures. Okay. And then once we have exam 2 is not going to cover the content that was covered in exam 1. And that's going to be, it's not going to, so let me rephrase that. It's not going to explicitly cover content that was covered in exam 1, right? So when I say explicitly, the reason why I say explicitly is because, as you're going to find out, this course is a sort of a course, and all courses are like that, but this is especially one of those courses in which the concepts start building on top of each other, right? So, I mean, it's important that you know the content for exam 1 before you're going to be able to do well on the content on exam 2. So it's very, very sequential. Having said this, what I mean by what the statement earlier was that I will not explicitly test content of module 1 in exam 2. Okay, so in exam 2, the explicitly testing will only be from module 2. Okay, does that answer the question? Kisne pucha tha ye? Okay, hopefully it does, right? So, and then exam 3, similarly module 3, exam 4, and then exam 5 is going to be scheduled at your final exam, but nevertheless, it's only going to be weighted 20%. And for all practical purpose, or for, I mean, if you do plan on that, you can skip exam if you want to, and because only 4 of them are going to be counted at the end of the day. Okay. I also want to just highlight these 3 quotations that I've actually put up on the course outline. So perhaps this is not what I put up last night or last evening. I mean, these are quotations that I added this morning, and the outline has been updated. So the first one is, let me read this out aloud. This is, as to methods, there may be a million and then some, but principles are few. The man who grasps principle can successfully select his own methods. the man who tries methods ignoring principles is sure to have trouble. And this is one of the guiding principles that you should internalize as far as the rest of your education in electrical engineering is concerned, and what this course is going to be about as well. So this course is about principles and not methods, right? So this course is about fundamental concepts. And if those fundamental concepts or those principles are strong, if you know those principles, I mean, there's no trouble. There's going to be no trouble for you in devising methods in your career or for the rest of the 2 years that you have remaining at LUMS and beyond in your academic career or your practical career as well, right? So, so this is, once again, very, very important. You need to not ignore principles, but rather internalize principles, because those can be used for devising methods, right? One of the other things I want to highlight here is right at the beginning of the class is this statement by Henry Ford, which is, whether you think you can or you can't, you are right. Okay, can somebody try to shed light on what this means?
Sir, can I try?
Yeah, go ahead, Manu.
Sir, I'm not sure, लेकिन I think कि अगर आप ये कहो कि I can do something तब भी आप ठीक हो, अगर आप कहो कि you can't do something तब भी आप ठीक हो, तो isn't it better कि आप सोचो you can do something?
Yeah, so
rather than
so that's a Manu, that would be a literal translation of what this statement is, right? So you're right in a sense. Somebody else, Hamza?
अस्सलाम वालेकुम सर।
वालेकुम।
सर हम इसको इस तरह इंटरप्रेट कर सकते हैं कि indecisiveness जो होती है आपके दरम्यान में, there is like in simple binary terms, either you are a digital for once, you are either a 0 or a 1, 0.5 वाला कोई हाल नहीं होता आपका, ठीक है? And that like इस तरह I would interpret it in that way.
Okay, nice, right? So I would have a different interpretation, but that's nice to know somebody else has a different interpretation. Ji, Hassan?
Sir, which Hassan?
Hassan
Ahmed. Oh. So I see this as attitude, as in, if you think you can, you will be able to. But if you think you can't, you won't be able to. So you're right in both cases. Okay. It depends on what you think.
Excellent. And I'll take a last comment from Masna and then we'll move ahead. Or Maz has Masna, Abhi, go ahead, please.
Yes, sir. I had the same answer,
same.
that both the options are correct.
Okay. Maz?
Sir, I think what most important is to think about doing something.
Yeah.
मतलब आपको सोचना है कि करना है, सही करते हो या गलत, that is a different case.
Okay, nice. All right. So my interpretation, the way I interpret this is very, very closely, actually exactly what Hassan said and Masna said as well, that it's actually about an attitude, right? Whether you succeed or whether you don't succeed, it's more about the attitude than your capability, because it's the attitude that leads to capability in the first place anyway, right? So it's important that you start out anything with the right attitude, and that right attitude should be confidence in your own self, and the confidence that you can do it. Because if you start out with the wrong attitude, I mean, if you're with the negative attitude of ye to mujhse hona hi nahi hai, right? If that's an attitude that you're starting out with, you will never be able to do anything, or you'll never be able to succeed in what you're trying to do. Okay, so a prerequisite, if you will, of doing something right is an attitude, or is the thought that yes, you can do it. I mean, that's extremely important, right? So I want each and every one of you to start out this semester in general, and EE310 in particular, right? That you will be able to do it. You can do it, right? You can achieve it. There are going to be obstacles along the way. There are going to be difficulties along the way, but yes, you can do it. Okay. And yes, Hassan Shabir, the body achieves what the mind believes. Exactly. So this is another very, very nicely put this is exactly what this statement means. Okay. And I think some of you may have been at the sophomore orientation or welcome that we had perhaps last semester, if I'm not wrong. How many of you were there? जो Ali Samik tha, who did that, and Isha did that, had a welcome for doubly sophomore. So if you recall, मेरे बारे में कुछ कहा गया था उधर, right? Ali Samik said something about me. Who can remind me of what he said?
Your course is the hardest.
I think he called you Master Shifu, I guess.
Yes, he called me Master Shifu. I was taken aback of it, but he did call me Master Shifu. And Shifu of EE department, exactly. That's what I think. Those were his exact words. Shifu of EE department. I'm not sure if you would have been able to see my expressions there, but they were of surprise and perhaps a positive surprise. And I think the reason why I would like to think the reason why he called me Master Shifu is not because of my beard or not because of the fact that I'm not that tall. It's rather because of the fact that I quote Shifu a lot. Actually, this particular quote of his, which is, if you only do what you can, you will never be more than what you are now. Right. So this is a quotation that I start out all of my courses with, and this is what you should start out your semester with, or your LUMS academic career with, or your anything that you do with, right? So we need to get out of our comfort zones and do the things that we cannot do, right? And that's the point of learning. I mean, the point of learning is to learn things that you do not know and do the things that you cannot do. Okay. So once again, I want each and every one of you to start out with that attitude, right? Which is actually related to this as well. Whether you think you can or you can't, you're right. The right attitude, the thought process of you can do it. And even though you don't know how to do it yet, but you will be able to do it ultimately during the semester or by the end of the semester. Okay? All right. Any questions here before any questions about the modalities of the course? Any questions about the grading breakup or instruments?
Variable relative grading.
That's not important yet. I mean, so it's not important to worry about the grades, but rather, I mean, if you just focus on learning, you'll get the grade. I mean, that's a byproduct. Okay. Any other questions?
Sir.
जी, who's this? जी हमजा.
जो आपने कहा कि ये मैथ इंटेंसिव कोर्स है, तो सर कोई ऐसे कॉन्सेप्ट्स हैं मैथ्स के जो हम एटलीस्ट हमें फ्रेशन अप कर लेने चाहिए?
Right. So one of those concepts is, which is on complex numbers. I am going try to. I'm not sure exactly if I'm going to have the time to do it, but I have that module in the beginning, right? So the first lecture has a reflection on complex numbers. The textbook, actually the reference book that. Okay, I think that's what I forgot to mention, right? So your textbook is this Alan Oppenheim, and so I would strongly suggest that you buy this book, right? And this is not going to be too expensive. I think this is the cheap version is available in the market. Just buy this because this is not only going to help you in this semester, but it's going to help you throughout. At least it does help me throughout, not from the fourth semester, but uske baad se ab tak help kariye. Okay. So this is what I would suggest that you buy. Now, there is also this reference book by Lighty, which is Linear Systems and Signals. And this book at the beginning has a background chapter, if you will, right? So it goes through the background material that you may need to know. And one of those is complex numbers. Of those is linear algebra. So I would suggest that you go through them. Perhaps that would give you a better idea. Kisne pucha tha ye? Hamza ne, right? So Hamza, you can go through that background material to help you prepare for what's coming up next, right? Having said this, कुछ series की बातें आएंगी, तो I will quickly review those, although, right? Not in a lot of detail, but I will quickly review some of the concepts, for example, complex numbers and series during the semester. Hassan, you have a question as well. Go ahead.
Sir, for those of us that are going to be available on campus, will you be available on campus?
Yes.
Would that be possible?
Hassan, I live on campus. So this is my home office, if you will. Lekin I do visit SSC very often. And if there's something you want to talk to me about, I will be more than happy to talk to you. Okay,
Thank you,
even
sir.
if there's a smaller group of people who would like some tutorial or and we can try to arrange something like that, right? With a smaller number of people, though, smaller groups.
Thank you.
Okay, would you be coming? So, how many of you plan to be on campus for your labs or for your courses? Yeah, we don't know yet, but like,
All EE sophomores will be there for our introductory circuits and DLC labs. Sorry to interrupt you, sir.
Okay, all right. So that's nice. That's nice. So even though we're going to be online here, we can have other arrangement as well. Okay, so Muneem, if Tahir did upload this background portion, I think that's excellent. Although I have some qualms about the copyright issues, we can try to overcome those somehow. Okay. Muneem, did you have the same comment or question? All right. So any question about?
No, I was just indicating can I be on campus.
Okay. So any questions about the grading, how the grading is arranged? I think Circus 2 might be very, very similar.
No, sir, we are having, I think, some final exam there and midterm there. Like, इस तरह का exam, like, based उनका setup नहीं है.
Who is this? Hamza?
Hamza Rafi, sir.
Hamza Rafi. Hamza, I talk to Tahir very, very often. We work very, very closely together. Last evening I talked to him, so he said something about exams. Maybe he's changed it now. I don't know. But nevertheless, okay, regardless of, so this is what we're going to try to do. Okay, I think especially in the online setting, this may work better, right? Okay, so I'm going to stop sharing this screen, and I am going to. If there are no questions about the modalities.
So okay, what are the modalities?
Ji, kya question about the modalities? Yeah. Ji, Ahmed?
Could you explain what the modalities are exactly?
What kind of modalities? Ji, Ahmed?
Okay, I kind of okay, forget the question.
I went through them in the beginning, right? So everything is going to be online, on Zoom,
okay,
in a synchronous fashion. Going to be.
Mode of communication. Okay, so I understood that. Okay.
Okay.
I thought you meant some sort of like graph related thing, like quiz type thing. Something.
Right. Okay. So what we're going to do today now is an introduction to signals and systems. So there's just a course overview of the kind of things that we're going to be looking at and why are we going to be looking at those things, right? So that's something we want to cover in the beginning. And if we have time, then we will move on to complex numbers. Okay. So let me set things up here before we begin. Right. Okay. So who knows what a signal is? I mean, if somebody can define a signal, one of the sophomores, if they can define what a signal is. क्या ज़हन में क्या आता है? I mean, when somebody says कि here's a signal, what does that mean? क्या आपके ज़हन में क्या आया? So Usman Nadeem. Okay, Mustafa, information. Mustafa says information. That's about right. So let me define that here. Let me give you a very broad sort of definition. So since the course is about signals and systems, so what I'm going to do is I'm going to give you a quick broad definition of what signal is, and then a quick broad definition. When I say a broad, is sort of not precise, but rather intuitive of what system is. So we're going to define signals and systems, and then we're going to see why is it important for us to be studying these concepts, right? So roughly speaking, right? So this is the definition. A signal contains information as Omar is saying information about, right? So signal containing information about some physical phenomena. About some physical phenomena, right? So that's what a signal is. But what's actually important as far as we're concerned is that that information, or that information about some physical phenomena, is a function of some independent variable, right? So is signal is contains information about some physical phenomena as a function of an independent variable. Independent. Right? So what could be examples of signals? Let me quickly give you some examples. The first and foremost example that you may all be familiar with is your electrical current, is your electrical voltage as a function of time, right? So this is, once again, I stress the fact that it has to be a function of an independent variable. So if you look at a voltage signal, right? So that is, so voltage as a function of time. So if I come across that voltage and if I plot that voltage as a function of time, I would say that that is a signal, right? So in my EE310 language, I would say that's a signal, okay? So this could be, for example, if this is the time axis, if this is the time axis, and this could be some voltage, and for example, a sinusoid with a certain frequency, with a certain phase. And I'd say this is a signal. This signal could be a sinusoid, it could be a square wave, and so on and so forth. But that function of time, the way the voltage behaves, is a signal. Okay? All right. Other examples could be right. So acoustic wave pressure as a function of time. Right? So what do I mean by that? So as I speak to you, right, how am I communicating with you? I mean, my vocal cords vibrate, and that creates changes in pressure, in air pressure, right? So if I were to somehow measure that pressure at any given location in space, right? And if I were to plot that against time, I would get some variation. And that variation as a function of time, variation in pressure as a function of time, I would say that is a signal because it conveys information about a physical phenomena. And that physical phenomena is that speech, if you will. Okay. So that itself is a signal as well. Okay. And there's the example, the list goes on and on. I will just give you one more, which is the speed of a car as a function of time. Right? It's just that this function does not have to be of time, by the way. I mean, this could be of another independent variable as well, right? So even though I've been saying time on all of these three examples, this could really be something else as well. So another example I can give you where it's not a function of time is, for example, a function of space. And you would say, KR, there's a 4G tower somewhere close to LUMS, and I want to map out, KG, what is the signal strength of the RF waves that are being transmitted from it as I move out, or as I radially move out or move away from the tower, right? So I would want to plot the signal strength as a function of the distance from the tower, right? And if I were to plot it out, that will be signal as well. And an example, I mean, so just a depiction of that could be, if this is the distance And the signal strength that I would see is going to be, by the way, as the distance increases, what you would expect? What would you expect the signal strength to? Should it increase or decrease, by the way? What do you think? Ji Hassan?
Decrease.
Decrease, right? So you would expect the signal strength to decrease because the electromagnetic waves suffer attenuation as they travel outwards from the source. Okay, so that would be a signal once again. Okay, so that's what a signal is. What about a system? Okay, so system is nothing but a black box as far as we're concerned. So is a black box which takes as input a signal, does something to it, and responds to it, and outputs a signal as well. Right? So it would be something which responds to an input signal and produces an output. And that output is also a signal. Right? So if I were to do a graphical representation for this, or graphical depiction of this, I would say my system is actually a box. And I'm going to discuss some examples in a bit. The system is a box which has an input, and this input is actually a signal, which is going to be a function of some independent variable. And the output is going to be a signal as well, a function of some independent variable. Right? And that box, that's something which responds to it, is something called a system. Okay? What kind of examples can we think of as far as systems are concerned? The simplest example, because almost all of us are electrical engineers here, at least in the enrollment list, I saw some exceptions. But even if you're not an electrical engineer, you would be familiar with with this example, which is an electrical circuit, right? An electrical circuit, think of the electrical circuit as, I mean, there's a bunch of resistors, where there's a bunch of capacitors or inductors connected in a particular fashion, and you provide an input voltage to the circuit, right? And then there are certain terminals at which you measure what the output is. I would say that electrical circuit is a system which has an input Vi of t, which goes into an electrical circuit, and it produces an output voltage V naught of t, right? So this box here is what this R's and C's and all of that I've combined together and depicted in a particular box. And so I just look at what the input is and how the output is related to the input. That will give you a description of what the circuit does or what the system does, right? So this electrical circuit would be an example of a system, right? The behavior of the system actually depends on how they're connected. I mean, the electrical components, how they're connected. Okay. Another example could be a car, for example. I'd say a car is a system, right? And the input to that is for example, amount of fuel injected into the engine as a function of time, right? So this would be the input, and what the output is speed of the car. As a function of time. Okay, and the relationship between the output and the input would depend on what kind of a car are we talking about? I mean, are we talking about Mehran, or are we talking about high-end, top-end sports car? Okay, so the behavior of the system is going to depend on some physical parameters, and those physical parameters relate to the make and model and so on and so forth. Okay, but we've been able to abstract it in the sense that there's an input, which is the fuel injected into the engine, and out comes the output, which is the speed of the car as a function of time, right? So this car would be an example of a system. Okay, and believe it or not, the human body is a system as well, right? And the human body is actually systems of system. I mean, in our high school biology classes, I mean, we would talk about digestive systems, and we would talk about circulatory system, and so on and so forth, and nervous system, right? So the body is a systems of systems, right? But let me just quickly give you one particular subsystem of that human body, right? And all of these examples are motivated by some of the applications that I'm going to talk about in just a bit, right? So this is a human body, or part of the system of the human body, which has an input, which is the electrical current in the motor cortex.
In the cortex.
Right, in the motor cortex, right? So, I mean, how does your brain actually communicate with your limbs, right? So you have neurons inside the brain, and they generate electrical currents, right? And those electrical currents somehow translate or transmit and go all the way up to through different processes to your limbs, and your limbs generate limbs are moved by electrical currents as well, right? So the brain में जो generate हो रहे होती हैं, those are called EEG signals. यहाँ पे muscles में generate हो रहे होते हैं, those are called EMG signals, right? But the process of motion is somehow generation of electrical currents in your human brain, and output is electrical currents as well, but in the muscles. As a function of time.
सर ये sorry to interrupt you, सर ये कौन सा cortex आपने बताया?
Motor cortex.
अच्छा, motor cortex.
Why is it called motor cortex, by the way?
सर क्योंकि ये मतलब सारे effectors जो होते हैं आपकी body के, उनको control करता है.
So motor is for motion.
Yes, sir.
Right. So these is muscles. Okay. All right. And let me just give you one more example, right? And that's an acoustic system, right? So this would be, for example, a room. And so there's an acoustic signal in. So let's say you're in an empty room, right? So if you speak at one end of the room, right, what you would hear at the other end, I mean, what would you hear? Would that be exactly what the other person spoke? या क्या चीजें ऐड होंगी उसके अंदर?
There will be noise attributed into
it. Right. So there will be
noise.
Pitch
might vary.
Okay.
The pitch might vary because of the distance it's traveled.
Okay. So the pitch is, so this is another, so pitch is varied not because of the distance it travels. Pitch is actually varied because of Doppler. Well, that's another aspect altogether. I mean, that's because of motion. Noise is added, so that's correct. Hamza? Did you?
Sir, it might depend on the room कि room अगर like कितना बड़ा है या क्या उसके अंदर like वो voice like वो signal जो acoustic signal है आपस में अपने आप से मतलब interfere करके तो that could also मतलब distorted सा signal हो सकता है इस वजह से तो it depends on the room itself.
Okay, depends on the room itself, and that distortion, there's a particular kind of a distortion that you would have all experienced. Yeah, Hassan?
Static. like
Echoes. Good, Ahmed.
Yeah, echo is what I was saying.
Right. So Hafsa, yes, that's correct. The volume of the voice would depend on the distance too. So the voice actually, the strength of the acoustic signal decays as a function of the distance. And more importantly, you would hear echoes, right? So there is a certain response that the room is going to induce, right? And that really depends on what the room looks like. I mean, if there's a bookshelf here, instead of the bookshelf being here, if the bookshelf was there, what you would hear at the other end is going to be different, right? So the relationship between what the acoustic signal at the output at one particular location as a function of the acoustic signal at the input at another location really depends on what the room looks like, right? Or what the kind of objects that you have in the room, right? And I can say that the room is a system because the input is a signal which is acoustic and output is a signal which is acoustic. Okay, so these are just 4 examples of systems, right? And the reason why I go through these, and I, by the way, for each one of these systems, you will have different examples of signals as well, right? So spanning multiple domains, right? And different areas of specialization, if you will, right? So this would be electrical circuits, right? So if there's an electrical circuits, the relationship between the input and the output is going to depend on some circuit theory, right? And some specific knowledge of the circuits. Okay. Yahan pe, I mean, there's some mechanics involved, right? Or other automobile engineering, if you will, and so on and so forth. I mean, this is some clinical things, right? And this is some acoustic things, right? So all of these 4 examples, okay, I think you can't see my screen. Okay, give me a minute. Right, so the point I was trying to make was that all of these 4 examples appear to be drawn from different areas, right? From electrical, from mechanical, from electromechanical, right? So from neurological systems and so on and so forth. Okay. But what we're going to try to do is try to come up with mathematical abstraction that can actually bind all of these seemingly disparate areas into a single framework. And that's the beauty of mathematics in the first place. That's the beauty of mathematical abstraction in the first place, that you just define a common language, right? You define a common language, which is the mathematical language that binds all of the seemingly disparate applications together under a single framework, right? And this is what I was talking about at the very beginning. I mean, with respect to principles and methods, right? So the principle is that mathematical abstraction. If you know the principles, you will be able to apply those methods for any one of these areas if you're comfortable with the underlying mathematical abstraction, which is the EE310 language. Okay, so my point here was that of mathematical abstraction. Right. So mathematical abstraction allows us to describe all these seemingly different areas with a common language, and that language is EE310 language. right? So that's why mathematical abstraction is necessary. And I mean, that is what we're going to be doing throughout the semester. We're going to be giving you that language which would allow you those principles to describe systems, regardless of what area they're applicable to. Okay? All right. Any question here? Okay. So all right. So let me quickly go through some applications. And once again, even though this course is not going to be talking about fancy applications where these things could be applied, I mean, rather, this course is going to be about equipping you with the fundamental principles, which you may end up using down the line for developing fancy applications. But nevertheless, let me just try to link up the 4 examples that I told you to some very nice, attractive, or cutting edge things that you could do if you are comfortable with that language that we're going to be talking about, right? So the first thing is, I mean, the point is that ye car wali cheez, for example, I mean, if you're familiar with this system, if you've been able to describe this mathematically, this car, okay, with, you know, Keji, as a function of time, if this is the amount of fuel that I inject into the engine, if you knew that how is that related to the speed of the car as a function of time, what kind of a fancy thing would you be able to build with this knowledge? Any ideas? क्या कुछ कर सकते हैं हम? If you knew this description of a car or the description of a car system. Ahmed, could you please mute yourself? Okay. Ji Hamza?
सर वी कैन बेसिकली एनालाइज जो फ्यूल हम डाल रहे हैं सर फ्यूल को आप इस तरह देख सकते हो जब आप ये व्हेन यू रेफर द अमाउंट ऑफ फ्यूल यू कैन लाइक लुक एट इट लाइक दिस वे कि मोल कितने फ्यूल के आप कंज्यूम कर रहे हो विद ईच लाइक केमिकल साइकिल जिसके अंदर आप एनर्जी प्रोड्यूस कर रहे हो यू कैन प्यूरिफाई योर फ्यूल इन सच एन एक्सटेंट इन सच अ वे कि आपके जो पर साइकिल आपकी जो मोलर कंजम्पशन है उससे ज़्यादा एनर्जी प्रोड्यूस हो ऐसा लाइक कॉम्पोजिशन निकाल सकते हो फ्यूल की थ्रू व्हाटएवर मींस पॉसिबल तो दैट कुड बी वन ऑफ द एप्लीकेशन
Okay, good, excellent. That could be one of the applications. That's an excellent application. Any other ideas? And I think Iraz sort of mentioned the same application, that important role in the efficiency of the car, right? So Mahanur?
Sir, I had the same point. It would improve the efficiency of the system.
There was somebody else who raised Muhammad. Right, Muhammad Masna, yes.
Sir, economy, we can check the economy of the car and how we can improve the car itself and its engines.
Okay, good.
And
so it's the same thing that the other people mentioned as well, right? So very nice. Any other ideas? I mean, or the idea that I want to give, which matches mine. Okay, so that is of cruise control. Right? You know what cruise control is, right?
Yes, sir.
So cruise control is systems in your car, right? And I mean, not in all cars in Pakistan, khas taur pe. But what you can do is you set a certain speed, and the car automatically maintains that, tries to maintain that speed, right? That is called cruise control. Now, in order to build a system which can maintain the speed of the car at a certain level, I mean, you need to know exactly what the system how it behaves, right? Right? Where the input is the amount of fuel, so you know how much fuel you would need to inject, right? In order for you to be able to achieve a certain speed which is desired. Okay, so that system is called a cruise control. You can have other very, very fine sort of requirements, which you could say, KG, what I would want is that my car should maintain a speed of 60 miles per hour or 60 kilometers per hour, plus minus, let's say 2 kilometers per hour. So there could be that variation. Okay? And I want to go from 0 to 60 within a certain time frame. Okay? And those are some additional constraints that you could specify. How would I design the cruise control system that allows me to achieve such a stringent sort of constraint, right? And the knowledge of the car system would allow you to achieve something like that. Okay, and typically how it's done is actually a course that you're going to see in the next semester or the semester after that, which is called control system, right? So you have this car system, which the input is fuel and the output is speed, right? And the way typically what this is done is you would pick up the speed here through a sensor, right? And you would sense कि गाड़ी इस वक्त कितनी स्पीड पे जा रही है, right? You would take it and you would feed it back and design some system here, and which is called a control, which controls how much fuel should be injected into the car as a function of time, where the input is a desired speed, right? So designing something which is this control here, this requires familiarity or expert knowledge, चले कहना चाहिए, knowledge of EE310. Right? Right. So Umar was saying something, the radar system which keeps you from changing lane unconsciously. That's excellent, but that system is slightly थोड़ी सी और चीजें आएंगी उसके अंदर. But that's excellent. That signal systems would allow you to, the language would allow you to build an application like that as well. Okay. Similarly, there's the system C, which was that of a human body. अगर आपको ये पता है somehow कि if this is, or you know the relationship between the electrical current in the muscles and the electrical current in the motor cortex, like any ideas of what you can do? I mean, let's try to think of some applications here. So you have the human body, right? जहाँ पे क्या हो रहा है? This is electricity in the muscles, right? And these electricity is used to stimulate muscle. That's how your muscles actually work, right? G, who raised his hand? Masna raised his hand first. Okay.
Sir, artificial limbs that work with electricity.
Excellent. Right. And anybody else? If Asad, did you have a different answer?
सर ऑलमोस्ट सेम, लेकिन कुछ लोग होते हैं जिनका बाय बर्थ ही नर्व्स पहुंचती नहीं है, तो उनके अंदर हम कुछ छोटे छोटे कंपोनेंट्स लगा सकते हैं ताकि उनके हाथ पांव हिले.
Excellent. Right. So that's also sort of artificial limbs as well, right? And this sort of knowledge would allow you to build artificial limbs. In the sense कि जी जहाँ पे, I mean, this is sort of broken here, right? And there may be patients who suffer from paralysis where these electrical signals are not being generated effectively, right? What you can allow them is something that can read your mind through something called EEG sensors. So you can place them on your head, or you can have electrodes actually inserted on the surface of the brain as well to detect those electrical signals. And they go into your own designed controller, right? So this is some electronics that you design, right? Which tries to do what? Which tries to replicate the body system. So you would need to know what the body system, how it works, in order for you to be able to replicate them. Masna, I'm going to come to you in just a bit, okay? Let me complete this first. And then what you would do is, with that electricity that is generated, you would be basically providing a bypass mechanism, if you will, okay, to stimulate the muscles, not directly through your nervous system, but rather something from the outside. I mean, बीच में एक तार अगर कटी हुई है, तो you're providing a bypass. ठीक है, that's essentially what you're trying to do. Okay, जी Masna.
Sir, was this the same technique used for Stephen Hawking?
Stephen Hawking did
The
not
wheelchair
have a motion system, did he? Wheelchair move करती थी उसकी उनकी.
नहीं सर, वो मतलब he couldn't speak और उसका वो
Yeah, I know. But he had, over the years, lots of different systems that were used for him. I'm not exactly sure which ones. I recall they had a system here as well, I mean, which was able to somehow pick up on some minor vibrations here to control a computer interface and others. But I can give you other examples where I saw some demonstration where they did this with a monkey. Right, they were able to bypass that normal route and design this artificial limb, if you will. Okay.
Okay. Thank you.
And somebody else raised their hand as well. Right, but the point here is, okay, with that signal, you would need that signals and system knowledge to be able to do things like this. Okay, and finally, just as a motivational example, is okay. The D system was acoustic system. Okay, so you have the acoustic signal coming in, you have a room, if you will, right? यहाँ पे acoustic signal आया, an acoustic signal out, and what I can do is, with sort of the language that we're talking about, is okay, if I can somehow replicate the response of the room, estimate, what I can do is I can perhaps feed this in to here, right? And have this thing added here, such that, so this is plus and this is minus, so that this is the output. What would I be able to achieve? And this is an application that people work on and been able to demonstrate things like this. What do you think? This could be a quiet zone. Okay. So if you can somehow estimate the room response, right, from one location to the other, and using this sort of methods, what you could try to do is to create a quiet zone at the other end of the room, right? By replicating that path, estimating that path, and somehow subtracting them and creating a quiet zone. Okay? And then many other applications, such applications that you could utilize. Ji Hassan.
So perhaps a simpler example would be active noise cancelling.
Yeah. So active noise cancelling is something similar. The noise cancellation phones is something similar, exactly. So this is actually, this quiet zone was from some application that I saw from a startup a few years ago. I'm not exactly sure how realistic those claims are, but what they claim is, okay, if they can put their device, for example, on this desk, right, they can essentially block out the noise from coming in from all other places. I mean, I'm not exactly sure how realistic is that, those claims. Again, that's what they started out with. Okay, I believe they were not able to get anywhere. Okay, any questions here? All right. Okay, so once again, the point in conclusion is that even though these are all fancy applications, lying at the heart of all these applications is mathematical abstraction, right? Is lying at the heart of all these methods are principles, are fundamental principles. And the objective of this course is to teach you those fundamental principles per se. I mean, so that's what we're going to be focusing on. So our objective primarily is not going to be on how these methods can be designed, but rather in characterizing the fundamental principles which govern these signals and which govern these systems. And standing on those principles, you would be able to design those methods, not in this course, but subsequently in other courses, hopefully. Okay, so this is a primer of why we're doing what we're going to be doing for the rest of the semester. Okay, if there are no questions, I'm going to move ahead with the review of complex numbers.
सर
जी हमजा.
सर इसमें आपने अकॉस्टिक सिग्नल वाली एग्जांपल में आपने पॉजिटिव और नेगेटिव साइन किस चीज को इंडिकेट कर रहे हैं?
Positive sign, negative sign को indicate कर रहा है कि यार there's a signal coming in from the direct path, and the way you would want to play something from artificially is so that what you play artificially cancels out the signal coming in from the direct path.
ठीक है सर.
ठीक है? It's not an easy task, by the way. It's not an easy task. But अब you play your things in exactly the same fashion कि वहाँ की wave इसकी wave से cancel हो जाए, acoustic waves. Okay, so this is perhaps too fancy. I mean, this may not work in this fancy of an application. All right. Okay, complex numbers. So this once again is from your the text that you see on your screen is from your reference book by Lati, the background section, and it just gives you a primer of complex numbers and why complex numbers are important, right? So as you know, complex numbers, and let me just try to read some of this content here. They are an extension of ordinary numbers. And I mean, people often have a hard time understanding why they exist in the first place, right? So why do we work with complex numbers? Let's see if some of you can try to answer that. Furqan, why do we work with complex numbers?
So because there are some values like under root -1 that are not defined in real
Okay.
like real numbers, so we needed some numbers to explain them.
Okay,
So we
nice.
created complex numbers.
Okay, right, excellent. I just want, so Hassan, please go ahead.
The one reason I can think of is waves and how sine and cosine waves can be described in complex exponentials,
Yeah,
which are easier to deal with.
easier to deal with. Excellent.
And with integrals and things like that.
Okay,
So
excellent.
it just helps with that.
Excellent. Right. So these are all valid points. And I mean, one of the things I want you to really, I'm sorry, I would want you to read this background material from the reference book. And I mean, one of the interesting things I found interesting was this statement here. This feeling of unreality derives, from here, I'm reading from here. So this feeling of unreality derives from their unfamiliarity and novelty rather than its supposed non-existence. Mathematicians blundered in calling these numbers imaginary, for the term immediately prejudices perception. Had these numbers been called by some other name, they would have been demystified long ago, just as irrational numbers or negative numbers were. Okay? So here's the point that the author tries to make is that long time ago, they were only positive integers, right? Positive numbers only. I mean, there were nothing as negative numbers on the on the number line, right? And then people had to invent negative numbers because of some applications that they came across, right? Similarly, they just had rational numbers at the beginning, right? And Pythagoras, for example, found out KR, if there's a triangle, right? And if that triangle is a unit unit base and unit perpendicular, the hypotenuse cannot be represented as a fraction, right? So that means that's irrational, right? So the irrational numbers had to be invented or had to be discovered, if you will. Okay. And similar is the case with imaginary numbers. Imaginary numbers or complex numbers came about because of some historical reasons, and those historical reasons I would urge you to go through this background information that's there in the reference book that talks about solutions to actually cubic equations. वहां से पता चला कि यार there has to be something which is root -1, right? So you would need something like that. And the point is that in mathematics, right? So here's the point. In mathematics, we assign symbols and operations any meaning we wish as long as internal consistency is maintained, right? So that's complex numbers are invented to enable us to ease us in many applications. And an example of this is an analogy of this is very nicely put in this equation that you see, or this figure that you see here. वो कहता है कि यार if you want to go from point A to point B, which lies in the same country, right? The longer path is through this route, which is a longer path, right? But you know that there's a shorter path in going from point A to B, but that shorter part has to cross through another country. And this analogy now applies to complex numbers. The use of complex numbers is very similar. If you want to solve a problem in the real domain, right? It's often, for many problems, it's often very easy, much easier to go to complex numbers first, or use complex numbers first, and then obtain a solution back in the real domain, which is country X. But in order to get to that solution from point A to point B in an effective manner, in an easier manner, you would have to cross into country Y, which is complex numbers, right? So this is an analogy that he gives why complex numbers are important and why they're used so much in engineering applications. Okay, so I would urge you to go through that. And for example, Hassan mentioned some application of waves, circuits के अंदर exactly similar, and many other applications in which complex numbers make our life a lot easier, right? And the country Y makes our life a lot easier, a shorter route from point A to point B. Okay? So we're running out of time, so this is where I'm going to stop, and I'm going to continue with the review of complex numbers from next class onwards, and some algebra of complex numbers quickly before we start with the actual signal and system stuff. Okay. Any questions here before we end? Ji Hassan.
So you gave us a few examples of what signals can be.
Yeah.
Originally, I would have thought, for example, if you had a graph of voltage with respect to current, I would not have considered that to be a signal.
Yeah.
So what's a counterexample for signals?
So the reason why the example that you mentioned is not a signal is because one of the variables is not an independent variable. Okay, so that's the first thing. So when I defined a signal, I said a signal is a function of an independent variable. Okay, so a counter example in the sense that जो signal है, वो that's a voltage as a function of time. I mean, did I understand your question correctly, or what do you mean by a counter example?
No, that is what I mean. Like,
so
basically, if we have,
so let me put it this way. Let's say there's this electrical circuit that's given to you. Okay, you take an oscilloscope and you take a probe and you just insert it at a particular point in the circuit. Okay, and on the scope you see a wave, right? The x-axis on that scope is what? Is time, right? And the y-axis is that voltage, right? So what you're seeing is a voltage as how the voltage behaves as a function of time, and that curve is a signal. Okay, clear, Hassan? Yeah.
But couldn't current? Yes, I understood that. But couldn't current in let's say through a wire also be a function of the voltage that you provide? So that would also be a signal.
But one of the variables is not an independent variable. Okay, because voltage and current, if you're through the same resistor, they're a function of each other.
Yes.
Okay, so that will not be an independent variable.
Okay. Thank you.
Okay, so I mean, you would just get a straight line if it's just a resistor. Any other questions? Okay. So if there are no questions, let me stop.